Okay, I just wanted to post an update on some experiments I've been doing. This is a modified Fuji circuit, Joule thief kind of circuit. I'm not at the point to fully figure out how to explain this in order for everybody to replicate it yet. I'm going to set about to do that, but before I do that I have to be able to replicate it myself. So I bought the parts to make another one of these, and when I get the second one working and eliminate all the variables from the system, then I will go ahead and post schematics so you guys can replicate it. This came about when I was experimenting. I wanted to, kind of in the idea of Daniel McFarlane Cook and those patents, I wanted to create something that I could ring with some current and they would keep running after being removed from the battery. Through that I tried many different things. I finally got to this, and this seems to do the effect I was after. What I've got here, this is a bunch of the ferrite rings. They're stacked end to end inside here. Then directly on that it's wound just like a Joule thief. We've got the two wires here coming in, they exit down here. Then I've got a secondary winding on here. Again, I'll need to draw this out so you guys can see the schematic. I have some diodes here. So let's not worry about too much about exactly how to replicate this at this point. I will post another video on that. I just want to show the effect. So what I've got here is I've got two 9-volt batteries. The only reason I have two is because they are so dead that together the two of them put about 8 volts into the system. But so yeah, you can just energize it, then you can completely take the batteries out of the system. There are no supercapacitors in this at all. These are electrolytic capacitors, and just so that you can see that the effect is truly running off the capacitors, I will remove them. So you can see we're down to 3 and the light's still running. 2, 1, now I'm going to remove it and the light went out. So we really are ringing the system and it's continuing. I mean, it's pretty hard to at least for me to wrap my mind around, but I've got these small, little electrolytic capacitors. They don't hold much in the line of power to speak of. What's interesting is I have some supercapacitors, and I'll show that in a second part in this video, but if you put a supercapacitor in here at the same voltage as the electrolytic capacitor, it will drop in voltage rapidly and not even power the light, as you would imagine would normally be the case if you've experimented with any Joule thief circuits very much. But in this arrangement that I've come up with, I'm able to take a little bit of the voltage and current that's in here and get it ringing and resonating within the system, and it just keeps going and going. So I'm going to reintroduce these these electrolytic capacitors back in. These are the same capacitors that was running on earlier. So you can see that the light comes on there as soon as I plug one in. So obviously, I was very excited to be able. Now I like to add more just because it seems to catch whatever's spiking back into this into the capacitors. It seems to me that the more of them you have, the more of a reservoir it kind of creates to catch that. So I'll go ahead and put as many as I can fit on here. One second here, folks. I'll just get these plugged back in. So, there we go. So again, no batteries in the system. I mean, I did have some little supercapacitors I've experimented with. They actually don't work. You don't want any batteries in this circuit. This is a circuit that runs without batteries. Just it'll run on one electrolytic capacitor. It seems to run the light better with a few more in play, but you don't need that many. So I will bring the batteries back in here. I'm just going to give it another ring here, and then I'm going to hook up the scope. So you really could create a circuit that you just energized every once in a while and just let it run. So again, just gave it a little ring. We'll disconnect everything, and we'll hook up the scope. See, I just emptied the supercapacitors the electrolytic capacitors, I just emptied them out there. I accidentally shorted it out. There's still enough that it's trying to run, it's trying to ring, but we'll just fire it back up here again. Let's turn the scope on. Yeah, if you short any of these electrolytic capacitors, they instantly lose their, it instantly stops the the continued ringing of the circuit. So anyway, there we go. We'll get the batteries out of here, and we'll take a look at this. Just let me set the scope up here. Let me just get it set here. Alright. So, hopefully you can see this. This is the waveform. It's on. Let me just change the settings here. Alright, let me just move it up so you can see. Again, this whole time this is running not connected to any battery. I'm disconnected over here, folks, and it's just ringing. You can see the waveform. This is 5-volt divisions. It says it's 226 hertz. And this will just ring and ring and ring. And the only thing that changes if you reintroduce some more current back into the system, we'll just spike a little more in here, is that the waveform will tighten up here a little bit. So you can see this is not a perpetual over unity device as this currently stands at all. What this is a basically just spiking some current into the system, and it just rings and rings and rings. So if I can eliminate more of my inefficiencies in the circuit and more of the places that I have loss, I'll be able to keep this running much longer than I'm at even now. And I've been doing that. Originally I didn't have this coil here. I had more of a different kind of Joule Thief type wound coil there. I've come up with this one. This one works better. So I just need to keep experimenting with this and trying different things. So yeah, just thought I'd give an update, show where I'm at with this. That's it, folks. No battery needed. I will again just show that it can run on one electrolytic capacitor. I'm removing these, and you see that the light is remaining lit. So we're down to one. See the waveform is still going. I'm going to remove that one, and the light will go out. Come on, it's stuck in there. There we go. So that's it. I will just as soon as I can get the instructions for replicating this figured out. Is that I've got no battery in this system right now, but what I do have is a supercapacitor and electrolytic capacitor. Now the supercapacitor has a lot more capacity for power to drive this circuit than this electrolytic capacitor, and they're both at the same voltage. They're both at 5.6 volts. So the supercapacitor is full. This is about a half full on the electrolytic capacitor. So now what I'm going to do is I'm going to remove the electrolytic capacitor. So it's out of the system right now. No other batteries or anything in this. Now I'm going to connect the circuit here to the supercapacitor and watch the voltage in the supercapacitor. You see it dropping rapidly. It lost a whole volt there almost instantly. It's going down, down, down. The CFL is not coming on. Now what I'm going to do is I'm just going to remove the supercapacitor and put in the electrolytic capacitor. And let's watch the light there as I do this. Okay, the light's on. The light's continuously running. No other batteries in the circuit. And to me, that's the effect that is so bizarre with this current setup.